Part 2 of the Module 3 problems, we're specifically going to look at factoring and then simplifying radicals and performing operations as radicals. So the first part is going to be the factoring. So number 15, we have 2x squared plus 8x plus 6. Anytime the number in front of x squared is something other than 1, you should always look for a GCF first. So I'm looking to see if there's a number that goes into 2, 8, and 6, and there is. That value is 2, which means I have a GCF of 2. So the first thing I want to do is factor out that GCF. So I'm going to take the 2 and put it on the outside, and now I'm going to divide every term by that value. So 2x squared divided by 2 is going to give us x squared. 8x divided by 2 is going to give 4x, and then 6 divided by 2 is going to give us 3. Now I want to factor the quadratic inside my parentheses. So I'm looking for values that multiply to 3, but add to 4. And those are going to be 3 and 1. So that means I'm going to have x plus 3 in one parenthesis and x plus 1 in the other. And I could have written x plus 1 first, then x plus 3. It doesn't matter the order in which I put the values in my parentheses, as long as they have the correct sign. Next, we're going to look at x squared minus 8x minus 20. So there isn't anything in front of x squared other than 1, so I can start looking for my numbers. So I'm looking for two numbers that multiply to negative 20, but add to negative 8. And because the 8 is negative, I know that the bigger of my two numbers also has to be negative. So that's going to be 2 and negative 10. So I'm going to have x plus 2 in one parenthesis and x minus 10 in the other. And again, I could have written it as x minus 10 in the first parenthesis, then x plus 2. Next, we have x squared minus 81, and this is a difference of squares. Anytime you have a squared term minus just a number, you want to check to see if both of those terms are perfect squares. Because if they are, they factor a certain way. And x times x gives us x squared, and 9 times 9 gives us 81. So that means in my parentheses, I'm going to have an x plus 9, and in my other parenthesis, I'm going to have an x minus 9. And again, I could have switched which set of parentheses had the minus and which one had the plus, and it still would have been correct. Number 18, we have 3x squared minus 7x minus 6. So the value in front of x squared is something other than 1, so I want to check for a GCF. And unfortunately, there is no value that goes into 3, 7, and 6. So I can't factor out a GCF. So what we're going to do is we're actually going to use the box method to factor. So we're going to put our 3x squared and our negative 6 in our top left and bottom right boxes. Now to figure out what goes in the other two boxes, instead of finding the numbers that multiply to negative 6 and add to negative 7, I first have to do a times c. So that means I have to do 3 times negative 6, which is going to give us negative 18. So I'm actually looking for the values that multiply to negative 18 and add to negative 7. So just like the problem above, the value in front of x is negative, so I know that my bigger number is negative, and it's going to be 2 and negative 9. So I'm going to put a 2x and a negative 9x in my remaining two boxes. It doesn't matter which one I put in which box. Now I can factor GCFs going across. So 3x squared and 2x, the only thing they have in common is an x. Negative 9x and negative 6 have a negative 3 in common. If you're trying to figure out if you're going to put a negative on the outside when you're looking at the row and column that starts with the x value, whatever the sign of the x term is the sign of the number you're going to factor out. So because this was a negative 9x, I knew that I was going to have to factor out a negative value. Now we want to look at the columns. So 3x squared and negative 9x, they're going to have a 3x in common. And 2x and negative 6 are going to have a 2 in common. So this time I factored out a positive number because the value in front of x was a positive 2. If ever you want to double check that you factored out your GCFs correctly, the values on the outside now have to multiply to give you what's in the box. And if they don't, then you know you factored out a GCF incorrectly. So that tells me the row and the column I have is in each set of parentheses. So we're going to have 3x plus 2 in one parenthesis and x minus 3 in the other. And again, I could have written it as x minus 3 first and then 3x plus 2. So our last problem says 8x squared minus 98y squared. It's very similar to the difference of squares problem we already did. So it's still a difference of squares because I have a squared term minus another squared term. But in this case, 8 and 98 are not perfect squares. So what I want to do is factor out a GCF. And there's actually a GCF of 2. 2 goes into 8 and 98. So when I factor out that 2, we end up with 4x squared minus 49y squared in the parentheses. I can now treat this like the problem above. So 2x times 2x is going to give us 4x squared, and 7y times 7y is going to give us the 49y squared. So when I write it in factored form, one set of parentheses is going to be 2x plus 7y, and my other set of parentheses is going to be 2x minus 7y. And I still have to have that GCF out in front so that if I were to distribute it back in, I would end up with what I originally started with. Now we're going to take a look at simplifying radical expressions. And the first thing we're going to do is looking at simplifying square roots that aren't perfect squares. So if I take the square root of 288 in my calculator, it's going to give me a decimal. But we want to simplify it so that it's an exact answer. So we want to break down 288. And it doesn't matter how you break down the number. There's a lot of different options to how you start out. And you can just start picking numbers to choose. So I'm going to start with 4 and 72. I know 4 breaks down as 2 and 2. I can break down 72 as 9 times 8. 9 breaks down as 3 and 3. 8 breaks down as 4 and 2, and then 4 breaks down as 2 and 2. Because this is a square root, in order to bring something outside, I have to have 2 of the same number. So if I'm looking for pairs of 2 of the same number, I actually have 3 different sets. I have a pair of 2s, a pair of 3s, and another pair of 2s. So when I pull those groups outside of the square root, I'm going to have 2 times 3 times 2, so all of my different pairs multiplied together. Then underneath the square root, I would multiply anything back together that didn't have a pair. And the only value I have left is 2. So on the outside, 2 times 3 times 2 is going to give us 12. And underneath the square root, we're going to have 2. Next, we're going to simplify the square root of 180 x cubed y squared z to the 4th. So first we're going to start by breaking down 180. And I'm going to do 10 times 18. When I break down 10, it's going to be 2 times 5. 18 I can break down as 6 times 3, and then 6 I can break down as 2 and 3. So I'm looking for groups of the same number. I have a pair of 3s, and I have a pair of 2s. Next, I want to take a look at the variables. So x cubed is x times x times x. Y squared is y times y. And z to the 4th is z times z times z times z. So similar to how in order to pull out a number I had to have 2 of the same thing, it works the same way for variables. I have to have groups of 2. So out of my x cubes, I have one group of x's, I have one group of y's, and in the z, I have 2 groups. So for my numbers, I'm going to have my 2 times my 3. I have one group of x's, so I'm going to have x. I have one group of y's, so I'm going to have y. I have 2 groups of z's, so that's actually going to give me z squared. Underneath my square root, I had a 5 without a pair, and I also had a leftover x. So both of those are going to go underneath my square root. My last step is go ahead and multiply the 2 and 3. So my final answer is going to be 6xyz squared square root 5x. Now we're going to take a look at simplifying a cube root. So the only difference between simplifying a cube root and a square root is the number of things that have to be the same in order for you to pull them out. So I'm still going to simplify 54 like I normally would. So I'm going to do 9 times 6. 9 becomes 3 and 3, and 6 becomes 3 and 2. So unlike the previous two problems where I had to have 2 of the same number, this time I have to have 3 of the same number. So I have one group of 3s. When it comes to the variables, so x to the 5th, I'm going to have 5x's. Z to the 6th, I'm going to have 6z's. And b to the 7th, I'm going to have 7b's. Just like with the values, I have to have 3 of something in order for it to come outside my square root. So I have one group of x's, we're going to have 2 groups of z's, and we're going to have 2 groups of b's. I already have a 6 outside of my square root, my cube root. So when I bring out my group of 3's, it has to multiply with the 6 that's already there. I have 1x, I have 2z's, so I have z squared, and I have 2 b's, which means I have b squared. Underneath my cube root, I have a 2. I have 2 x's, so that becomes x squared. I have no z's, and I have 1b. Lastly, I have to multiply my 6 times 3, so we're going to end up with 18 xz squared b squared, and then underneath the cube root, 2x squared b. It's important because this is a cube root, you write the little index indicating that we are talking about a cube root. Next, we're going to take a look at a division problem. So I have the square root of 18 over the square root of 32. What we're going to do here is we're going to first simplify each square root on its own, and then simplify our fraction. So I'm going to break down 18 as 9 times 3, and then 9 becomes 3 and 3. So I have a group of 3's. 32, I'm going to break down as 4 times 8, the 4 becomes 2 times 2, the 8 becomes 4 times 2, and the 4 becomes 2 times 2. So I have 2 groups of 2. Now when I rewrite my problem, I'm going to have 3 square root 3 over 4 square root 2. Now when we're dividing with radicals, we don't like to leave a square root in the denominator. So what we're going to do is we're going to multiply the top and the bottom by the square root of 2, so we can get rid of it in our denominator. Our numerator is going to become 3 square root 6, because we can multiply our square roots. And then on our denominator, the square root of 2 times the square root of 2 is going to become the square root of 4. And 4 is a perfect square, and its square root is 2. So we end up with 4 times 2. Once I multiply in my denominator, we end up with 3 square root 6 all over 8. Our last step is to make sure that any square roots we still have can't simplify, and check to see if numbers outside of square roots can simplify. So the square root of 6 can't simplify, and 3 over 8 can't simplify either, so this would be our final answer. The last thing we're going to look at is adding, subtracting, multiplying, and dividing radical expressions. So the first thing we want to do is look at a subtraction problem. So we have 3 square root 5 minus 5 square root 5. In order to add or subtract radicals, you have to make sure you have like radicals. And that means that the value underneath the square root has to be the same. In this case, we have square root 5. So when I subtract like radicals, we subtract the numbers outside. So I want to do 3 minus 5, and we're going to end up with negative 2 square root 5. You want to treat the square root like a variable. If I were to do 3x minus 5x, I wouldn't change the x's, it would just become negative 2x. It's the same way with like radicals. You don't change the number that's underneath the square root for addition or subtraction. So next we have an addition problem. 3 square root 12 plus 2 square root 300. These are not like radicals, but it doesn't mean that I can't simplify them to become like radicals. So first I'm going to break down the square root of 12, which is 4 times 3. And 4 can break down as 2 times 2. So I now have a pair of 2's. 300 I can break down as 100 times 3. And 100 I can break down as 10 times 10. Now, I can technically simplify 10 and 10 into 5 and 2, but I already have a pair of 10's, so I don't need to continue simplifying it if I've reached a pair of 10's. So I now have 3 times 2 on the outside of my first square root, and underneath I have a 3, plus, and then I have a 2 times 10, and underneath the square root I have a 3. So 3 times 2 is going to give me 6 square root 3, plus 2 times 10 is going to give me 20 square root 3. So when I add my now like radicals, 6 square root 3 plus 20 square root 3, I'm going to end up with 26 square root 3. Now we're going to take a look at multiplying. So number 26, we have the square root of 14 times 3 minus square root 7. Just like when we're multiplying polynomials in part 1, we can distribute when we're multiplying radicals. So I'm going to distribute the square root of 14 into the parentheses. 3 and square root 14 can't multiply, so it's going to become 3 square root 14. Then we're going to have minus, and 14 times 7 can multiply because they're both underneath the square root, and we're going to get square root 98. The problem doesn't stop here. Because we are multiplying radicals, I have to check to make sure those radicals don't simplify once I've multiplied. 14 doesn't simplify, but 98, which we multiplied 14 and 7 to get, I can break down as 14 times 7, and 14 I can break down further as 2 and 7. I now have a pair of 7's that I can bring outside of my square root. So we're going to end up with 3 square root 14 minus 7 square root 2, which are not like radicals, so this is going to become my final answer. Our next problem, we have 2 minus square root 6 times 2 plus square root 6. So I can FOIL just like I did with polynomials here. So we're going to multiply everything in the first set of parentheses by everything in the second set of parentheses. So 2 times 2 is going to give us 4. 2 times square root 6 is going to be 2 square root 6. Negative square root 6 times 2 is going to give us negative 2 square root 6. And then negative square root 6 times 6 is going to be negative square root 36. My 2 square root 6 and my minus 2 square root 6 are going to cancel. So I'm going to be left with 4 minus, and then I can take the square root of 36, it's going to be 6. And 4 minus 6 is going to give me negative 2. So sometimes when you multiply radical expressions, you can end up with a number as your answer. Next, we have 6 plus 4 square root 3 squared. Just like the problem in part 1 where we had something squared, we're going to have to expand it in order to multiply. So we're going to have 6 plus 4 square root 3 times 6 plus 4 square root 3. And now we can FOIL like in our previous problem. So 6 times 6 is going to give us 36. 6 times 4 square root 3 is going to give us 24 square root 3 because I can multiply 6 and 4. 4 square root 3 times 6 is going to give us 24 square root 3. Then we do 4 square root 3 times 4 square root 3. 4 times 4 is going to give us 16, and then underneath the square root, we're going to have 9. 24 square root 3 and 24 square root 3 are like radicals, so I can add them together and get 48 square root 3. Square root of 9 is 3, so my last term is going to become 16 times 3. So when we do 16 times 3, we're going to get 48. So we end up with 36 plus 48 square root 3 plus 48. 36 and 48 are like terms, so we end up with 84 plus 48 square root 3 as our final answer. That's the end of our review problems for Module 3, Part 2. Please let me know if you have any questions about Part 2 or Part 1 about Module 3.